Hey there, gearheads. Jay Leno here, and let me tell you, the automotive world is in the midst of a revolution. Electric vehicles, or EVs, are no longer a futuristic fantasy. They're here, and they're here to stay. But what makes them tick? The answer lies in the heart of these machines: electric motors and powertrains. You see, for over a century, we've relied on the internal combustion engine. It's been a good run, but let's face it, it's a bit outdated. Electric motors, on the other hand, offer a cleaner, more efficient, and frankly, more exciting way to power our vehicles. They're simpler, quieter, and deliver instant torque for a driving experience that'll put a smile on your face. In this essay, we're going to dive deep into the world of electric motors and powertrains. We'll break down the basics, explore their advantages, and even touch on the exciting advancements on the horizon. So buckle up, folks, because the future of driving is electric. Now let's talk about the real stars of the show: electric motors. These ingenious devices are what transform electrical energy into mechanical energy, making your EV move. There are two main types you'll find in most EVs: AC induction motors and permanent magnet motors.
AC induction motors are like the workhorses of the electric motor world. They're reliable, durable, and relatively inexpensive to produce. Tesla uses these in their Model S and Model X.
Then there are permanent magnet motors, known for their efficiency and power density. These are found in many EVs, including the Chevy Bolt and Nissan Leaf. Both types have their pros and cons, but the bottom line is this: they both get the job done. They provide smooth, silent power, eliminating the need for noisy engines and clunky transmissions. Plus, with fewer moving parts, electric motors require significantly less maintenance than their gas-guzzling counterparts.
Of course, electric motors are just one part of the equation. To get an EV moving, you need a complete powertrain system. Think of it like this: the motor is the muscle, but the powertrain is the nervous system, connecting everything and making it all work in harmony.
A typical EV powertrain consists of four main components: the electric motor, the power electronics, the transmission, and the battery. The motor, as we discussed, provides the power. The power electronics act as the brain, controlling the flow of electricity from the battery to the motor. The transmission, much simpler than its counterpart in a gas car, transfers the motor's power to the wheels. And finally, the battery, the heart of the EV, stores the electrical energy that powers the entire system. Together, these components create a seamless and efficient system for propelling your EV down the road.
Now, one of the things I love most about EVs is their simplicity. Compared to the labyrinthine workings of an internal combustion engine, electric powertrains are a breath of fresh air. Fewer moving parts mean fewer things that can go wrong. Think about it: no more oil changes, no more spark plugs, no more timing belts to replace. EVs drastically reduce the need for regular maintenance, saving you time and money in the long run. Plus, with fewer components to wear out, EVs tend to have a longer lifespan than traditional gas-powered vehicles. This simplicity also translates into a quieter, smoother ride. Say goodbye to the roar of the engine and the vibrations of a traditional drivetrain. EVs offer a serene driving experience, allowing you to enjoy the open road in peace and tranquility. Section 5: Torque and Efficiency, leaving gas guzzlers in the dust. But let's not forget about performance. One of the most exhilarating aspects of driving an EV is the instant torque. Unlike gas engines, which need to rev up to reach peak power, electric motors deliver maximum torque right from the get-go. This means lightning-fast acceleration off the line. You'll be pinning your passengers to their seats as you effortlessly zip past gas guzzlers at stoplights. And it's not just about speed. This instant torque also makes EVs incredibly responsive and fun to drive, but the advantages don't stop there. Electric motors are inherently more efficient than internal combustion engines. While a gas engine might only convert around 20 to 30% of its fuel energy into actual power, electric motors boast an impressive efficiency of over 90%. That means more of the energy you put in goes directly into moving the car, not wasted heat. Section 6: Regenerative braking, putting energy back in the tank. Here's another cool thing about EVs, regenerative braking. This innovative technology allows EVs to recapture some of the energy normally lost during braking and feed it back into the battery. It's like having a little power plant on board. Here's how it works. When you hit the brakes in an EV, the electric motor actually reverses its role and acts as a generator. This converts the kinetic energy of the moving vehicle back into electrical energy, which is then stored in the battery for later use. Regenerative braking not only extends your driving range, but also reduces wear and tear on your traditional brakes. It's a win-win situation for both your wallet and the environment. Section 7. Power electronics, the brains of the operation. Now let's talk about the brains behind the operation power electronics. These sophisticated electronic components act as the control center of the EV, managing the flow of electricity between the battery and the motor. Think of power electronics as the conductor of an orchestra, ensuring that all the different instruments are playing in harmony.
They regulate the speed of the motor, control the amount of torque produced, and manage the regenerative braking system. Power electronics play a crucial role in maximizing the efficiency and performance of your EV. They're constantly monitoring and adjusting the system to ensure that you're getting the most out of your battery and enjoying a smooth, responsive driving experience.
Of course, no discussion about EVs would be complete without talking about charging.
Unlike gas cars, which require frequent trips to the gas station, EVs can be conveniently charged right at home, at work, or at public charging stations.
There are 3 main levels of EV charging: Level 1, Level 2, and DC fast charging.
Level 1 charging uses a standard household outlet and is the slowest method, typically adding 2 to 5 miles of range per hour.
Level 2 charging requires a dedicated charging station and is significantly faster, adding 10 to 60 miles of range per hour.
DC fast charging, the fastest method, can deliver up to 80% charge in as little as 30 minutes.
It's important to note that charging times can vary depending on the vehicle's battery capacity, the charging station's power output, and other factors. The world of EVs is constantly evolving, with new advancements emerging all the time. One of the most exciting developments on the horizon is solid-state battery technology. These next-generation batteries promise to be safer, more energy-dense, and faster charging than current lithium-ion batteries. Imagine EVs with driving ranges of over 500 miles on a single charge and charging times comparable to filling up a gas tank. Solid-state batteries have the potential to revolutionize the EV industry, making electric cars even more appealing to the masses. And it's not just about batteries. Engineers are constantly working on improving electric motor designs, developing new materials, and refining power electronics to make EVs even more efficient, powerful, and affordable. As we look to the future, it's clear that electric motors and powertrains are poised to transform the automotive industry. With their numerous advantages over traditional gas-powered vehicles, EVs offer a cleaner, more efficient, and more exciting way to drive. The transition to electric mobility is well underway, and it's only a matter of time before EVs become the norm. Governments around the world are implementing policies to encourage EV adoption. Automakers are investing heavily in electric vehicle development, and consumers are increasingly embracing the benefits of electric driving. The road ahead is electric, and it's a road paved with innovation, sustainability, and a whole lot of fun behind the wheel. So there you have it, folks. The world of electric motors and powertrains is a fascinating one, full of innovation and potential. From the instant torque and efficiency to the simplicity and regenerative braking, EVs offer a compelling alternative to traditional gas-powered vehicles. I, for one, am excited about the future of electric mobility. It's a future where we can enjoy the thrill of driving while reducing our impact on the environment. So, what are you waiting for? Join the electric revolution and experience the future of driving today.